Well, good morning, afternoon, or evening, depending on when you happen to be viewing this. This is going to be our lesson video for today, March 17th. The first thing that I want you to begin with is the activator, which is a Google Doc, and it's set up that you can actually just type your answers on the Google Doc and submit it to me through Google Classroom when you're done. This morning, we're going to be finding the solution to systems of equations. So you'll see the instructions on there say to use the Desmos graphing tool and to find the ordered pair solution to each of these systems of equations. All right, so go ahead and go to that, and I'm going to get set up here and model it on the smartboard for you. All right, so then, if you happen to be following along, here is the Google document on your Google Classroom with the assignment here that says using the Desmos online graphing tool, find the ordered pair solution for each of the following systems of equations. So all I do is just come right up here to Desmos and type in my first one, y equals negative 3x plus 2. Hit enter. And then my next one is y equals 2x minus 3. And the next thing I do, once I have both lines graphed, is I just move my cursor over there to where they both intersect one another. And I see here that my ordered pair solution is 1, negative 1. So that's what you should have typed on your sheets, is 1, negative 1. And then to do the next one, I can simply just X these out. And I've got x equals 3. So I just come up here, x equals 3. And y equals negative x plus 1. So again, I see where both of my lines intersect each other. And if I just move my cursor and hover over that point of intersection, I see here that I have the ordered pair of 3, negative 2. So that's what you should be recording on your sheets, is 3, negative 2. And if you've done that, you can go ahead and X those out. And my next one is y equals 1/3 x plus 3, and y equals negative 2x minus 4. So come over to Desmos, y equals 1, and then I hit my slash key, 3x plus 3. And then my other was y equals negative 2x minus 4. So again, I see where both of my lines intersect. Hover over that ordered pair solution, and that shows me that I have negative 3, 2 as my answer. Then I've got y equals 1/4 x plus 3. 1, use your slash key, arrow x, 1/4 x plus 3. And then I've got y equals 2x minus 4. So that's where my lines intersect. And again, I hover over my ordered pair solution, and I can see that it is 4, negative 4. Or excuse me, 4, 4. I'm sorry, it's 4, 4. All right, and then finally, I've got y equals 2x minus 4/5. And y equals 2x plus 3. And if you look at that, neither of those two lines there are parallel lines. So hopefully you remember that is a no solution. So there is no solution to this ordered pair systems, or there's no solution to this systems of equations. Additionally, if you notice that both of them have the same slope of 2x. So if you remember, same lines with the same slope are parallel lines, and parallel lines never intersect. Okay, so that is our activator for today. So hopefully you got all those right. Please make sure you have the ordered pair solutions typed on the Google Doc, and you can go ahead and submit that through Google Classroom. And now we'll move on to the next part. All right, so where we left off last week, we had been talking about factoring polynomials. And so what I want to briefly do right now is go over what we already know about how to factor a polynomial equation. We learned two ways to do this. The first way that we learned was doing what we call the greatest common factor, okay? So for example, if I were to write on the board something like 2b squared minus 2, and if I were to ask you to factor that using the greatest common factor method, what you're going to do is look at both terms and see what they have in common. So I have a 2b squared here and I have a 2. So it's pretty clear to me that the greatest common factor here is going to be 2. So when I factor the 2 out, or do what we call undistribute, that leaves me with 2b squared minus 1. Okay? Because like I've shown you before, if I were to redistribute that back, like so, I would end up with 2b squared minus 2, which is the same thing that I started with. So that's what we call the greatest common factor method for factoring a polynomial, okay? Then the other method that we learned for factoring polynomials was simply finding common terms for each of them. So, for example, if I were to write up here on the board something such as n squared minus 6n plus 5, okay? In this case, I'm looking for two numbers that when added together would equal -6, and when multiplied together would be a +5. So one of the ways that I showed you to do this, as we have practiced with our diamond math, is I would put my sum up here, which is 5, or excuse me, my product up here, which is 5, and my sum, which is a -6. And then using what I know about factors, what two numbers, when added together, would equal a -6, and when multiplied together would equal a +5. So those two numbers in this case would be -1 and -5. Because -1 plus -5 gives me a -6. -1 times -5 gives me a +5. So then my factors here would be n minus 5 times n minus 1. And were I to multiply that out, n times n, that's going to give me n squared. N times a -1 is going to be minus n. -5 times n is minus 5n. And the -5 times a -1 gives me +5. So when I then go to writing this in standard form, because after I multiply, I always want to write it in standard form, I wind up with n squared minus 6n plus 5. So I know there that I have the correct factors. All right, so what we're going to do today is what we call the sum and difference of squares. And the sum and difference of squares is not that difficult. In fact, it's already pretty similar to what you've been doing. If I were to write a problem on the board, such as x plus 5 squared, What that basically means is I'm going to do x plus 5 times x plus 5. So were I to write that out, I would have x plus 5 times x plus 5, because that's what the 2 means, is to multiply it by itself. And then if I distribute, that gives me x squared plus 5x plus 5x plus 25. So now when I go to write this in standard form, I have x squared plus 10x plus 25. Okay? Now the reason I'm showing this to you is because the common confusion would be to think I can treat this binomial like a monomial. Because when you have a monomial, you distribute to everything inside parentheses. But however, this is not a monomial. This is a binomial. Therefore, I have to do it this way here, okay? And treat that exponent the way I've treated it. All right, so that's what we would call, for example, the sum of squares. Now let's look at something else. Let's suppose that I had, instead of x plus 5 squared, if I change that to x minus 5 squared. So same thing, I would set it up. Let me just zoom in for a moment here, a little bit for you. I would set it up the same way as x minus 5 times x minus 5. And then I'd go ahead and distribute. So that would give me x squared minus 5x minus 5x plus 25. And then when I go to write that in standard form, I would have x squared. That's the 8 o'clock bell. Minus 10x plus 25. Okay? So this is what we call sum and difference of squares. All right? So it can work either way. Now, here's the thing that will tend to confuse people. All right? And this is what I want to focus on now, is let's suppose I start off with x squared minus 81. Okay? So notice here this is a binomial, and I don't have a middle term. All right? So when I go to factor this, same thing, I'm looking for two numbers that when multiplied together are going to equal a negative 81, but at the same time when they're added together are not going to give me a middle term. So if I think about 81, if I use my diamond math principle here, I'm looking for two terms that when multiplied together would equal 81, and when added together are going to give me a 0. So you've probably already figured out that it's going to be negative 9 and 9. That should be negative 81. I think I said 81. That should be negative 81. Okay? So negative 9 and 9. Because negative 9 times 9 is, or negative 9 plus 9 is 0. Negative 9 times a positive 9 gives you negative 81. All right? So let's go ahead and factor this. Write this as factors and see if it works. So I've got x plus 9 times x minus 9. All right, so if I go ahead and distribute this out, so there's my x squared term, minus 9x, plus 9x, minus 81. So if I go to simplify this and put it in standard form, I can look right here and see 9x minus 9x, negative 9x plus 9x becomes a 0. So I have x squared minus 81, which is the same that I started off with. Okay? So this is what we call sum and difference of squares. All right, so let me show you another one. Let's suppose that I have x squared minus 49. All right, so this is another one. Since you all are really good with your fact families, let's think about it again. I'm looking for two numbers. So if I use my diamond math, two numbers when multiplied together are going to equal negative 49. And then two numbers when added together are going to equal 0. So that's pretty simple again, negative 7 and 7. Because negative 7 times 7 is a negative 49. Negative 7 plus 7 is going to give you 0. So if I was going to write this as factors, I'd have x plus 7 times x minus 7. Okay? Let me just zoom out a little bit here. All right. So factor them, or excuse me, distribute and multiply. So x times x gives me my x squared minus 7x plus 7x minus 49. Okay? So, negative 7x plus 7x gives me 0. So I have x squared minus 49. Okay. So what you're going to be doing for your assignment today is the first part of it is expressed as a trinomial. So when you see your problems on there, for example, you've got a u plus 3 squared. All right, so you're going to do just like I showed you before, is you would rewrite this as u plus 3 times a u plus 3, and you would go ahead and multiply it out. Then you're going to get to the ones that say factor. So you've got something like t squared plus 4t plus 4. So when you see t squared plus 4t plus 4, okay, all right, what the instructions want you to do is to write this, as it says here, as the square of a binomial. So to write this as the square of a binomial, we know that two numbers when added together equal 4 and multiplied together equal a positive 4 would be t plus 2 times t plus 2. But if you're going to write this as the instructions say as the square of a binomial, you could just write it as t plus 2 squared. All right, so that's how I want to see your answers. Remember, you can scan this, take a picture of it with your phone, and upload it to Google Classroom. Remember, Thursday on Discovery Edge, you're going to have an assessment on all this stuff we've learned on polynomials. If you have any questions, comments, concerns, you know how to reach me. Have a great day. And this production was brought to you by Mr. Gillard and the Pixel 4. Have a great day.